Hello, Byte and Apple crew. Welcome. Today, we're going to embark on a deep and fascinating journey into a concept that represents a fundamental shift in how we experience software. We're going to talk about Apple's liquid glass. In the long and storied history of digital interface design, certain moments mark a fundamental shift in our relationship with software. From the skeuomorphic textures of early mobile operating systems to the stark flatness that followed, each era has sought to define the ideal bridge between human and machine. Apple, a perennial architect of these shifts, has introduced its next major evolutionary step: liquid glass. This is not merely a new coat of paint or a simple visual theme. Liquid glass is a sophisticated design philosophy and a dynamic digital metamaterial, conceived to make software feel more organic, intelligent, and harmoniously integrated with the physical devices it inhabits. It represents the culmination of decades of learning, from the friendly translucency of Mac OS X's Aqua interface and the real-time blurs of iOS 7, to the fluid adaptability of the iPhone's dynamic island and the immersive dimensionality of visionOS. This is a comprehensive guide to the core concepts of liquid glass. We will deconstruct its visual properties, explore its intelligent and adaptive nature, and outline the key principles for its application. This journey will be structured around the insights of its creators, providing a detailed, yet crystal clear, understanding of this new chapter in human-computer interaction. Let's dive in. At its heart, liquid glass seeks to solve a fundamental challenge of modern UI design: how to create distinct, tappable, and functional layers of interface without obscuring the content beneath or cluttering the screen. Previous solutions often involved opaque cards or simple frosted glass blurs. Liquid glass proposes a more elegant, physically intuitive solution. The principle of lensing is focused on sculpting light. The primary visual characteristic that defines liquid glass is a concept called lensing. In the physical world, we are all intimately familiar with lensing. It is the phenomenon we observe when looking through a drop of water, a magnifying glass, or the curved side of a drinking glass. The light passing through the object is bent and distorted, warping the appearance of whatever lies behind it. Our brains have been trained since birth to interpret these distortions. We intuitively understand that this warping signifies the presence, shape, and even the motion of a transparent object in front of a background. Liquid glass harnesses this innate understanding. Instead of simply scattering light like a traditional blur effect, which diffuses and obscures details, liquid glass actively bends, shapes, and concentrates light in real time. Imagine a small, rounded liquid glass button floating over a photograph. You can still see the photograph through the button, but the part of the image directly beneath it will appear subtly warped, as if viewed through a perfectly smooth, clear pebble. The edges of the button are defined not by a hard, artificial line, but by the way the light bends most dramatically at its circumference. This creates a powerful visual cue that provides clear separation and communicates layering, all while allowing the content underneath to shine through. This technique allows controls to feel ultra-lightweight and transparent, yet remain perfectly distinguishable and tappable. The interface feels less like a stack of separate, flat layers and more like a cohesive, three-dimensional space. Organic motion and fluid responsiveness is a fundamental unit of liquid glass. How a material feels is as important as how it looks. The design of liquid glass was holistic, meaning its visual appearance and its motion were conceived as one inseparable system. The inspiration here comes from the natural movement of liquids: smooth, responsive, and seemingly effortless. Now we move to energizing on interaction. When you touch a liquid glass element, it doesn't just register the tap with a static color change. It responds by instantly flexing and energizing with light. A subtle, internal glow emanates from your fingertip, spreading through the element like a ripple. This makes the interface feel alive, satisfying, and directly responsive to your input. The gel-like flexibility, what's that all about? Liquid glass possesses an inherent, gel-like flexibility that communicates its transient and malleable nature. When you drag an element or interact with a slider, the material appears to stretch and contract in tandem with your movement. For example, a slider control made of liquid glass allows you to see the value underneath it with crystalline clarity through its lens, while the shape of the slider itself subtly flexes as you move it. This fluidity aligns the interface with the dynamic, nonlinear nature of human thought and motion. Materializing transitions is a core functionality. Objects made of liquid glass don't just fade in and out of existence. They materialize. This is achieved by gradually modulating the lensing effect. An element begins to appear as a faint distortion in the background, which intensifies as the light-bending properties increase until the object is fully formed. The reverse happens when it disappears. This ensures a graceful, optically consistent transition that feels more natural than a simple opacity fade, preserving the integrity of the material. Seamless morphing and shape-shifting brings a sense of fluidity extends beyond simple interactions to the very structure of applications. In modern apps, users are constantly moving between different states and contexts. Liquid glass is designed to make these transitions seamless by dynamically morphing between layouts. Imagine a toolbar with several buttons. When you switch to a different section of the app that requires a new set of controls, the old liquid glass toolbar doesn't vanish to be replaced by a new one. Instead, it fluidly reshapes itself. Buttons may slide, combine, or transform into the new configuration. This maintains the concept of a singular, floating plane of controls that adapts to your needs. The interface feels less like a series of disconnected screens and more like a single, intelligent canvas. This principle is beautifully illustrated in how menus are presented. When you tap a button to reveal a menu, the liquid glass bubble of the button simply pops open, expanding to reveal the menu items contained within. The transition is lightweight and occurs directly at the point of interaction, creating a clear and direct relationship between the action, the tap, and its result, the menu. With these foundational properties, lensing, organic motion, and seamless morphing, liquid glass establishes a new paradigm for how apps not only look, but how they feel to use. Fundamentally more organic, immersive, and fluid. The adaptive system showcases intelligence in context. A truly modern interface material cannot be static, it must be intelligent. Liquid glass is designed from the ground up to be adaptive, constantly and subtly adjusting itself to its size, its content, and its environment to ensure clarity and legibility at all times. A multi-layered, adaptive composition explains how liquid glass is not a single, monolithic effect. It is a composite of several dynamic layers that work in concert. Unlike previous materials that had a fixed light or dark appearance, each layer of liquid glass continuously adapts based on what is behind it. First, adaptive shadows. As you scroll text or complex imagery behind a liquid glass element, its shadow will automatically become more prominent to create additional separation and maintain the perception of depth. Second, dynamic tint and range. The material's base tint and dynamic range are not fixed. The system analyzes the background content and adjusts these properties to ensure that any text or symbols on the glass remain legible, while still allowing as much of the content as possible to show through. Next, automatic light or dark switching. For smaller elements, liquid glass can independently and automatically switch between a light appearance and a dark appearance. If it floats over a dark background, it will adopt a light, luminous quality. If the background becomes bright, it will seamlessly transition to a darker variant to maintain contrast. This allows it to feel perfectly at home in any context, letting the app's content be the star. Scaling with size and substance lays out how liquid glass change as it scales. When it flexes and morphs to a larger size, for example, when a small button expands into a large menu, its material properties simulate a thicker, more substantial object. It casts deeper, richer shadows. The lensing and refraction effects become more pronounced. A softer, more diffuse scattering of light appears on its surface. These subtle changes enhance the perceived depth of the element, making it feel more physically present and aiding in the legibility of the content it contains. Platform unification and environmental awareness. Liquid glass is a cornerstone of Apple's unified design language across iPhone, iPad, and Mac. The same principles are applied across all platforms, creating a cohesive experience that scales with the canvas. On iPad and Mac, liquid glass sidebars and toolbars form a distinct functional layer that floats above the content, giving users a more expansive and immersive workspace. A key detail is the precise relationship between the UI and the hardware. Liquid glass elements are designed to nest perfectly into the rounded corners of windows and physical screens, maintaining concentricity, a state where curves share the same center point. This creates a pleasing and harmonious geometric relationship between the software and the device itself that on larger surfaces like a Mac sidebar, liquid glass exhibits an even greater level of environmental awareness. Light from colorful content within the main app window can subtly spill onto the surface of the sidebar. This light doesn't just tint the surface. It realistically reflects, scatters, and even bleeds into the shadow the sidebar casts, much like it would in the physical world. This reinforces the material's context and its sense of elevation within the interface. What is the intelligent scroll edge effect? To maintain the crucial separation between the floating UI layer and dynamic content, liquid glass works in concert with scroll edge effects. As content scrolls up to meet the bottom of a liquid glass toolbar, the effect gently dissolves the top of the content into the background. This visually lifts the toolbar above the moving content, ensuring that floating elements like titles always remain clear and legible. Like the material itself, these effects are adaptive. If dark content scrolls underneath, causing the glass to switch to its light style, the scroll edge effect intelligently switches from a fade to background effect to a subtle dimming, once again prioritizing contrast and legibility. In specific cases where a pinned view, like a column header in a table, sits directly below a toolbar, a hard style effect is used. This applies a uniform, clean edge instead of a gradual fade, providing an extra degree of visual separation needed for more complex, layered layouts. What are the principles and best practices of working with liquid glass? Let's check out. To harness the full potential of liquid glass, it is essential to understand its internal structure and the guidelines for its use. Its magic lies in its holistic design, where every layer and behavior is part of a sophisticated, interconnected system. Here are the layers of the system. Highlights layer. Liquid glass exists within a virtual environment containing light sources. These sources produce highlights on the material's surface that respond realistically to its geometry. During certain interactions, like locking the phone, these lights move, causing highlights to travel across the element and define its silhouette. In some cases, the lighting even responds to the physical motion of the device, making the material feel aware of its place in the real world. Adaptive shadows. As mentioned, shadows are not static. Their opacity intelligently increases over complex backgrounds, like text, and decreases over simple, solid backgrounds to ensure elements are always easy to spot without being visually overpowering. Interaction glow. The glow that appears on touch is not just a simple animation. It starts directly under your fingertip and spreads fluidly throughout the element, even propagating to nearby liquid glass elements, creating a connected and responsive system. Focus states. The material's layers work together to guide user attention. When a window on Mac or iPad loses focus, the liquid glass elements within it automatically shift their appearance, becoming less prominent and visually receding, to clearly signal their inactive state. Critically, all these nuanced behaviors are built in. Designers and developers get this sophistication automatically when applying the material. Rules of engagement. How and when to use liquid glass. While powerful, liquid glass is not meant to be used everywhere. Its application should be deliberate and hierarchical. Reserved for the navigation layer. Liquid glass is best reserved for the primary navigation and control layers of an app that float above the main content, for example, toolbars, tab bars, sidebars, menus. Applying it to content elements like a table view would create visual competition and muddy the UI hierarchy. Avoid glass on glass. Stacking liquid glass elements on top of one another should always be avoided. This creates a confusing and cluttered interface where lensing effects and adaptive behaviors conflict with each other. When placing an element on top of a liquid glass surface, use standard fills, transparency, and vibrancy effects to make them feel like a thin, distinct overlay. Material variants, regular versus clear. There are two primary variants of liquid glass, each with specific use cases. They should never be mixed within the same interface. Regular. This is the default, most versatile variant. It includes all the visual and adaptive effects discussed: lensing, dynamic light, /dark modes, adaptive shadows, etc. It is designed to provide excellent legibility in any context, over any content, and at any size. Clear. This is a specialized variant that is permanently more transparent and does not have adaptive behaviors. Its purpose is to allow the richness of media-rich content, like photos or videos, to show through more dramatically, to maintain legibility for any symbols or labels placed on it. The clear variant requires a dimming layer to be applied to the content underneath it. Clear should only be used when three conditions are met. The element is placed over vibrant, media-rich content. The content layer will not be negatively impacted by a dimming effect. Any text or symbols placed on the glass are bold and bright enough to be legible against the dimmed background. The new tinting, color with physicality. Liquid glass introduces a new, sophisticated way of applying color that respects the principles of the material. Instead of applying a flat, opaque color overlay, which would break the illusion of transparency, the new tinting system works more like real colored glass. When you select a tint color, the system generates a range of tones. These tones are then dynamically mapped to the brightness of the content underneath the tinted element. The color will subtly change its hue, brightness, and saturation depending on what's behind it, without deviating too much from the intended color. This not only emphasizes the physicality of the material, but also enhances legibility and contrast. This powerful tinting should be used selectively to bring emphasis to primary elements and actions, such as a main, buy, or submit button. Tinting every element would create visual noise where nothing stands out. Built-in accessibility shows how inclusivity is a core tenet of the liquid glass design. The material automatically supports system-level accessibility settings, which act as modifiers on its layers without sacrificing its essential character. Reduce transparency makes the material frostier and more opaque, obscuring more of the background for users who find transparency distracting. Increase contrast makes elements predominantly black or white and adds a contrasting border for maximum legibility. Reduce motion decreases the intensity of some lighting effects and disables the elastic, gel-like properties for users sensitive to motion. Apple's liquid glass is more than an aesthetic update. It is a holistic system designed to redefine the interaction between user, software, and hardware. By drawing inspiration from the intuitive physics of light and liquid, it creates an interface that is simultaneously powerful and quiet, responsive and serene. Through its core principles of lensing, organic motion, adaptability, and holistic design, liquid glass delivers a unified language that feels at home on any device. It introduces a more fluid, dynamic, and immersive experience that aims to make our interactions with technology feel less like a series of commands and more like a natural extension of our own movement and thought. This is the start of a new chapter in visual and interaction design, and its influence will undoubtedly shape the digital landscapes of tomorrow. So that was liquid glass, and this concludes this edition of Byte Chronicles. Hope you like the insights, and thanks for watching. We'll see you in the next one. Till then, keep biting.